All right, hello, we are back with lesson 6.3, graphing another cannonball. So it says the function is defined by d equals 50 plus 312t minus 16t squared. Gives the height in the cannonball. Gives the height in feet of a cannonball t seconds after the ball leaves the cannon. What do the terms 50, 312t, and negative 16t squared tell us about the cannonball? So hopefully you were able to answer this question by yourself based on 6.2's video, because I kind of talked about that with that equation or that function. So 50 is telling us that is the height that the cannonball was launched from or fired from. 312t tells us that the upward velocity is given by 312 feet per second. So that's kind of like takes care of the linear portion. But then what does negative 16t tell us? 16t squared, excuse me. What does that tell us? Well, this represents the effect of gravity. This represents the effect of gravity pulling it down to the ground. All right, probably should have used a smaller pen so I could have fit more there, but it's all right. So moving on, it says, using graphing technology to graph the function, adjust the graphing window to the following boundaries. So hopefully you guys remember how to do this on Desmos. I went over that several times. We did the wrench. So if you forgot how to do it, you should have Googled it. So I would describe this as it's increasing after it's being launched and then decreasing. It has a peak, which looks like it's at 10 on the x-axis and maybe like 1600 on the y. So this tells us like basically what we see in everyday life, or like I already talked about, that whatever goes up must come down, right? So that football, that volleyball, okay, we've seen that before. So describe the shape of the graph. Everybody could have said something different again. B, it says estimate the maximum height the ball reaches. Well, that was something that I noticed when I was looking at the graph. So I would estimate it between 1500 and 1, 2, 3, 4, 5. So these are going by 16, 17, 18, 19. Okay, cool. So I would estimate this between 1500 and 1600, much closer to 1600. And it happens, when it says when, it's asking for the time. That happens after 10 seconds. So after 10 seconds, it reaches this peak and it starts coming back down to the ground. Then it says estimate when the ball hits the ground. So I'm looking and it hits here when it crosses the x-axis. So I'm going to estimate that to be about 19.5 seconds after the ball was launched. Just a little bit before 20 seconds. And it says what domain is appropriate for this function. So if you do not know what domain is, hopefully you Googled it before submitting this worksheet. If you didn't, I encourage you to pause the video and try and understand what this word means. What does domain mean? And what does it mean in this situation? So hopefully you looked up what domain is. Here, I would say the appropriate domain is between 0 seconds and 20 seconds. And why would I say that? Well, because if you look after 0 seconds, where is the cannonball? Excuse me, not after. Before 0 seconds, where is the cannonball according to this picture? It's down here. The cannonball can't be inside of the earth, before 0 seconds. That doesn't make sense. And then over here, same thing. Once it hits the ground, it's on the ground. It's not plummeting through the ground, through the earth. So it really only makes sense for this to have a domain between 0 and 20 seconds. All right, now that is 6.3.